1, 2, 3, come on!
Hi, I'm Teacher Giovanni and welcome to Math TV Lessons channel. Today our topic is all about proportion. But before that, I will be showing you two triangles, the first triangle and the second triangle. Actually, the two triangles have different measurements. So let's start from triangle number 1. So, as you can see, the longest side of the triangle measures 5 inches. This side and this side, actually the two sides here are have the same measurement. So this side measures 3.5 inches. So here in the second triangle, as you can see, the longest part or the longest side measures 12.7 centimeters, while this side measures 8.9 centimeters. In order for you to understand about the basic concept of proportion, let us multiply the measurements of the sides of the two triangles alternately. Okay, so here, let me show you the two triangles. Okay, so as you can see here, in the first triangle, the longest side measures 5 inches, and we will multiply that measurement to the alternate part or the alternate side of the other triangle. So here 5 inches times, we'll multiply it to the side, that is 8.9. So 5 times 8.9, if we are going to multiply the two numbers, that will be 44.5. Another one, we will also multiply this longest side in the second triangle to the alternate sides of the other triangle here. So that is 12.7 centimeters times 3.5 inches, or 12.7 times 3.5. If we are going to multiply the two numbers, the answer is 44.45. If we are going to round it off, that would be 45 equals 45. So the two triangles are equal. If we are going to put the triangles together, as you can see, they have in the same size. So it means the two triangles are equivalent, or the two triangles are proportional to each other. In order for you to understand deeply about proportion, I encourage you to watch this video until the end, because I will discuss here step by step about proportion and the different parts of proportion, such as direct proportion, inverse proportion, and partitive proportions. I know that you're so excited to learn today, so let's go. Let's start our lesson.
Proportion is formed by two equal ratios. Example, 1:2 equals 2:4. In expressing ratios, it is very important to have the order of the terms corresponds correctly to the order of the things being compared. Let's go back to our example. 1:2 is to 2:4. Let's say 1 is referring to a cup and 2 here referring to tablespoons. For example, 1 cup of milk is to 2 tablespoons of sugar, equals 2 cups of milk is to 4 tablespoons of sugar. The first term and the third term should be in the same quantity, while second term and the fourth term should be in the same quantity also. This is an important skill you need to master for you to be able to find if one of the terms is missing. So 1:2 is to 2:4. Let us know the different parts of proportion. We have these means. The middle terms are what we call the means, and the outer terms are what we call the extreme. What are the middle terms? We have 2 and 2. What are the outer terms? We have 1 and 4. In proportion, the product of the means is equal to the product of the extremes. Let's find out. Let us multiply the terms inside and also multiply the terms outside. So, what are the terms inside? We have the 2 and 2. So, we are going to multiply 2 times 2, that is 4. We will also multiply the outer terms. As you can see, the product of the means is 4 and the product of the extremes is also 4. So, they are equal. So, means 1:2 is equal to 2:4. Or the two ratios are proportional. They are called proportion. There are three kinds of proportion. We have direct proportion. As one quantity increases, the other quantity increases at the same rate. Example of this: you make an orange juice with a ratio of 2 tablespoons of powdered juice and 1 glass of water, and decided to double the amount of ingredients so that you can share with your friend. Instead of 2 tablespoons of powdered juice and 1 glass of water, you make 4 tablespoons of powdered juice and 2 glasses of water. The amount of powdered juice increases from 2 tablespoons to 4 tablespoons. The number of glasses of water also increases from 1 glass to 2 glasses. This is an example of direct proportions. We have another kind, inverse proportion. As one quantity increases, the other quantity decreases. Inverse proportion can also be called as indirect proportion. Example: it takes 6 days for one person to clean the whole ground. So the owner decided to hire 2 persons so that it will be finished in 3 days. It takes 6 days for one person, and it takes 3 days for 2 persons. As the number of persons increases, the number of days to finish cleaning become lesser. So this is an example of indirect proportion. If you analyze the problem, it is very clear that when there are many people working together, the number of days to finish working become lesser. So if you decided to make a house and then want to finish the house early, you need to hire many people to work for it. And that is an example of indirect proportion. Lastly is partitive proportion. A whole is divided into parts that are proportional to the given ratio. Example: you have 100 pesos in your wallet. You want to give 50 pesos to your sister, 30 pesos to your nephew, and 20 pesos for your friend. Meaning, when you add the amount of money you gave, the sum is equal to 100. So, partitive proportion means the sum of the parts is equal to the whole. Let's have problem number 1. Jean prepares calamansi juice for her visitors. For every cup of calamansi juice, she used 5 calamansi. If she makes 3 cups, how many calamansi are needed? Before you are going to answer the question, you have to analyze first the problem and categorize it: direct proportion, inverse proportion, or partitive proportion. You have to consider the ratios given in the problem. We have, for every cup of calamansi juice, she used 5 calamansi. So we can form a ratio out of it. Every cup means 1 cup, and then 5 calamansi. So the ratio is 1 cup is to 5 calamansi. So if the question is, if she makes 3 cups, how many calamansi are needed? If we are going to understand what will happen to the number of cup of calamansi juice and the number of calamansi needed, all of them should be increased. So when cup of calamansi increases, the number of calamansi to be used will also increase. So means this problem is a direct proportion. To easily solve the problem, we have to make a table. Divide the table into two columns. The first is the number of cups, and the second column is the number of calamansi needed. In the first row, we are going to put the first ratio given. We have every cup of calamansi and 5 calamansi. That represents as 1:5. We are going to put 1 below the number of cups, and we are going to put 5 below the number of calamansi needed. In the second row will be our next ratio, which is 3 cups and the number of calamansi needed. But here, the number of calamansi is unknown. This is what we are going to find. So, we put 3 under the number of cups and we put n below number of calamansi needed. N represents to the number to be found. So we have now 1:5 and 3:n. Under the number of cup columns, we have 1 and 3. Under the number of calamansis needed, we have 5 and n. If we are going to use arrows to represent direct proportions, it will look like this. So, since it is direct proportion, we will make arrows beside the columns, which is directly proportional to each other. So we will draw an arrow at the right side of the column, and we also draw an arrow to the left side of the column, pointing down since it is direct proportion. These arrows will serve your guide on how to make an equation. So we start from up to down. So we start from the first column. We have 1 going to 3. So that would be 1/3 equals the number of calamansis needed. We have from 5 going to n. So that would be 5/n. So our equation will be 1/3 equals 5/n. And then we are going to cross multiply 1 times n. Then 3 times 5. 1 times n is n, and then 3 times 5 equals 15. So n equals 15. So it means that if she makes 3 cups of calamansi juice, she needs 15 pieces of calamansi. As you can see in the table, the number of cup increases from 1 cup to 3 cups, and the number of calamansis needed from 5 to 15. So all the quantities increases, so it means that this problem is a direct proportion. This is an example of a direct proportion. As the number of cups increases, the number of calamansi also increases. In a direct proportion, as one quantity increases, the other quantity increases at the same rate, and vice versa. We have problem number 2. 2 painters can paint a room in 4 hours. How many painters are needed to paint the room in 1 hour? If we analyze the given problem carefully, we can deduce that the greater number of painters, the smaller number of hours needed to paint the room. Like in our first problem, we have to make, in the first column we have the number of painters, and the second column is the number of hours. Let's go back to the problem. 2 painters can paint a room in 4 hours. This shows the ratio of 2:4. 2 painters for 4 hours. In the first row, we have here the 2:4. We are going to put 2 under the number of painters and 4 under the number of hours. Next is, how many painters are needed to paint the room in 1 hour? What is given here? The given here is an hour. So what would be the unknown? The number of painters. So we will represent n for the number of painters and put 1 under the hours column. So under the number of painters, we have 2 and n. Under the number of hours, we have 4 and 1. The same in direct proportion. We will also use arrows in order for us to make an equation easily. But this time, the arrows should be indirectly proportional or inversely proportional. One must go down and the other one must go up, or vice versa. For this example, we will put arrow down to the left column and arrow up to the right column. So it means 2 comes first and n comes next. So that would be 2 over n. And the other one, 1 over 4. To form an equation, that will become 2 over n equals 1 over 4. We are going to cross multiply. 2 times 4 equals n times 1. That would be 2 times 4 is 8 and n times 1 is n. So the value of n here is 8. So it means there are 8 painters needed to paint the room in 1 hour. As you can see in the table, the number of painters increases from 2 to 8, while the number of hours decreases from 4 hours to 1 hour. So it means they are indirectly proportional, or indirect proportion, or inverse proportion. The problem shows that as the number of painters increases, the number of hours it would take to paint the room decreases. This situation illustrates two quantities are inversely proportional. This is an inverse proportion. In an inverse proportion, an increase in one quantity causes a decrease in another quantity. Another example. Divide 100 in the ratio of 1:1:2. What is the third number? This problem is an example of partitive proportion because the whole is divided into parts such as 1:1:2. As what I have said in the early part of this video, that partitive proportions means the sum of the parts equals to the whole. 1:1:2 here are not real numbers. It only represents ratio. What we are going to find here is the common partition. And this common partition is represented by n. So what will you do here? You are going to multiply each part to the common partition, such as 1 times n, 1 times n, and 2 times n. 1 times n equals 1n, 1 times n equals 1n, 2 times n equals 2n. As what I have said, that the sum of the parts equals to the whole. So we are going to add all the parts. We have 1n plus 1n plus 2n equals 100. 1n plus 1n plus 2n equals 4n. 4n equals 100. What will you do here? Your goal is to find the value of n. So be sure number 4 beside n will be removed. But you cannot easily take it away. So what will you do? You are going to divide 4n by 4. What you did to 4n will also be in 100. 4n divided by 4 equals 1n, or n. So 100 divided by 4 is 25. So the value of n here is 25. Is this the final answer? No, because the question is, what is the third number? And the third number is 2n. 2n is the same as 2 times n. So what are we going to do here now? we have to substitute the value of n. What is n? That is 25. So that will be 2 times 25. 2 times 25, that is 50. So the third number is 50. If you want to know if your answer is correct, you can also find the value of 1n and 1n. So let's try. 1n will be 1 times 25. 1 times 25 is 25. Another one, 1n equals 1 times n, or 1 times 25. That is 25. We have to add the three parts. 25 plus 25 plus 50. That is 100. So means our answer here is correct. Those are all about proportions and the different kinds of proportions. Let's have a short review. We have the direct proportion, inverse proportion, and partitive proportion. Direct proportion, as one quantity increases, the other quantity increases at the same rate. Inverse proportion, as one quantity increases, the other quantity decreases. And in partitive proportion, a whole is divided into parts that are proportional to the given ratio. Since we are now done discussing the different kinds of proportions, I want to challenge yourself. I want you to identify the following problems if it is direct proportion, inverse proportion, or partitive proportions, and then answer the following problems after all. Let's find out if you really understand the topic that I am discussing today.
Okay, so we are now done with our lesson about proportion, and I hope that you will never forget what you have learned about proportion, because I know that proportion is very important in our life. And one good example of this are architects. Architects use proportion to make a miniature model of a house before realizing it, in order for them to visualize the actual design of the house they are going to build. So, once again, I'm Teacher Giovanni saying, math is minds. Math is not a difficult subject if you're willing to learn. Thank you so much for watching and have a great day. Bye-bye.